Hello, everyone. Let's discuss another Leetcode problem today. Today's problem is problem number 70, climbing stairs. Although this is on the easier side, this is one of the fundamental problems from recursion and dynamic programming. So if you solve this problem, and if you're new in dynamic programming, you can build a nice, concrete, basic, okay, how to convert a recursive algorithm into a dynamic programming algorithm. And also, this is in the blind 75 list. Okay, so the problem description says you are climbing a staircase and it takes n steps to reach the top. Okay, so each time you can climb either 1 or 2 steps. Okay, and so how many distinct ways are there to climb to the top? So n steps I have to climb, and I can take 1 step or 2 steps at a time. So the number of unique ways. Okay, so let's look at some of the examples here. The first example says we have like two steps, right? So how can I climb this? So let's say we can, obviously the simple one is like, this is the ground, right? We can climb just 1 step and another step. That's it, right? 1 plus 1. So 1, 1, that's one solution. And the second solution is, say, what if I just climb, say, 2 steps at a time, right? Okay, so that's another solution. Now, what about, like, are there any other solutions? So what about if I climb, say, 1 step and then try to climb like 2 steps? Can I do that? Well, I cannot do that, right? I cannot, there is no step after 3, so that's a wrong thing. So I cannot do 1 and 3, sorry, 1 and 2, because there is no third step. Okay, so that's invalid. So there goes the first one. Now let's look at the second example here. So in the second example, we have, say, 3 steps. So 3 steps, 1, 2, 3. And this is the ground. So I can start with, say, simple one. Let's do it. 1 step, another step, another step. 1, 1, 1. One result, right? That's one way. What about if I do, say, 2 steps and 1 step? 2 and 1, right? That's another way. Nice way. And the third one, let's do another one. So what about 1 step and then 2 step? So 1, 2. Are there any other? Well, there is no other way, right? I cannot just do, say, a 2 and another 2. Can I do that? Like, can I do, say, 2 and then another 2? Well, there's 4. There is no 4th step, so that's wrong. Okay, so let's think about this problem, how we can solve this. I think if we draw a tree, first of all, I encourage everyone to think about this and then come back. Okay, so if you're coming back with some thoughts, probably you already have figured it out, or if you haven't figured it out, let's discuss. So say initially we have, say, n steps left, right? So we have to like climb n steps. So we can take 1 step. So that means we have to do like n minus 1 steps, or we can just take 2 steps, but still we can do n minus 2 steps, right? So how many ways can we say that number of ways to climb n step is actually, you see, we have introduced 2 ways, right? 2 ways. We don't know like how many more ways will spawn from this, but for now we can say that it's n minus 1 plus way of n minus 2, right? So that means we can define it recursively. Let's do further. Let's say number of n is, say, 5. Okay, then let's replace it with 5. So that means 4 steps left. We still have 4 steps, and we still need to go like 3 steps. Now, when is my success? Success is when I reach, say, 0, when I reach 0, right? That is one success. And failure is if I go to like beyond 0, that means -1, something like that. That's failure. So let's say from 4 steps, we can go to like, still we have to climb 3 steps, or we have to climb 2 steps from 3, 2. And if we take 2 steps, still 1 step is left. From 2, we can get like 1 step, or we have reached 0 steps. So this is a success. That means we have reached the top. This means we have reached the top, right? This is a success. Okay, and then let's say if from 1 we can just go 0, this is also a success. This is a success, right? Now can we go -1? Like I have to climb 1 step and I am taking 2 steps. That's invalid, right? That's invalid. I cannot do that. Remember, there is invalid case. And then you can see we are actually, yeah, so from 2, we can go to 1 and 0. This is a success. And then from 1, we can go to 0. That is another success, right? Okay, from 3, we can go to 2 or 1. And from 2, we can go to 1 and 0. This is a success. From 1, we can go to 0. This is a invalid step. From 1, we can go to 0, right? So you see another, so 1, 2, 3, 4, 5, 6. How many ways? Oh, here we also had 1, 7, 8. So there are like 8 ways. Now, another thing to very important thing to notice here is, you see, we actually solve the same problem again and again. Say, here is a problem. Hey, how can we solve, like climb 3 steps? We also have the same problem here. Okay, so why don't we use a cache? A cache, right? We can use a cache and then say, this is an array, right? So can we say that here we will try to calculate this. So, and this, in this step, we will calculate like mem of 4, right? So can we say like cache value of 5, this is going to be mem of 4 plus 3. Can we say that? Yeah, we can do that, right? Now, here is the thing. You see, we are calculating like this also, like, yeah, twice. So why don't we just calculate it here? Then we can get rid of all the things here, right? So we calculate it here. What value do we get? Mem of 3, right? This value. So when we actually call this, we already have this, right? So we just take it here and return it to this, right? So we calculate it once. What about 2? You see, we have this problem here, also here, right? So we just calculate it here, and then we can just use that value for this whole thing, right? Similarly, we are calculating, say, 1 here, also here. So why don't we calculate it here, and then we don't need to do all these things. So initially, this recursive algorithm looks like, you see, the depth of the tree is n, and this is a binary tree. So there are like 2 to the power n operations, right? Each of the nodes is actually one operation, one function call. So this is like order of this algorithm becomes order of 2 to the power n. Instead, if I just use this cache value and calculate it and later use it, then you see we get rid of all the branches, and pretty much we can just do this part, this calculation, and the order becomes like order of n. Amazing, right? And the memory that is being used is, we are actually keeping a memory of size n, right? Or n plus 1. I will describe it when I am coding. So it's, the space is like order of n, right? Also, if you think about the caller stack, the caller stack is also, that is also the calculation of the memory. So you can see we will just go down just n steps. So order of n. Okay, now the base cases. Base cases are, one of the base cases are like, if we are reach here, so then return 1. And another one is like important checking is if you reach here, sorry, here, then sorry, not this one, actually I made a mistake. So if you reach a negative value, so if we take 2 steps from here, so this is a return 0. That means we cannot, if we reach a negative, like there are -1 steps left, that's not valid, right? Okay, so let's solve this problem using the same memoization technique that we discussed. So we need a cache for memoization, an integer array of, let's take size n+1. In that case, we can match the index with the number of steps remaining. Okay, and then initially what we are going to do is filling this array up with -1. Okay, and then let's create a function because we want to pass this cache into the recursive function. So let's say, and let's rename it remaining. That means how many steps are remaining. Okay, and okay, so if remaining is 0, that means we have nothing is remaining. That means we have found a way, right? We found one way. We return 1. If remaining is less than 1, that means we have tried an invalid step. We have gone less than 1. Suppose 1 step was left and we tried to take 2 steps. That's not a valid way. Okay, next, if this was never calculated before. That means this climb stairs helper, let's say helper function, was never called before. That means still this value is set to -1. In that case, we can call this, so we can recursively take 1 step. That means the remaining would be -1. We'll pass this, or remaining will be -2. Okay, so we calculate the number of ways. If I take 1 further step, calculate the number of ways if we take further 2 steps, and save that calculation in this. And then we return this. Okay, so if this is done, so after we do this, right? After we do this, this is calculated. So next time is this climb, if this climb stairs helper function is called with the same remaining value, this is not going to be executed because there will be some other value here, and we'll just return this. Okay, so let's call this function with n steps remaining, and this cache, pass the cache, and this will return mem value of n, index n, right? So we'll just return that thing. Or if you want to make it easy, you just say int I equals to this and return I. Okay, let's make it easy. So this will return mem array of index n. Okay, let's try to run this. Okay, so here, what was the mistake? Oh, you see, I have a illegal character, an extra character. Okay, let's run it again. Yep. And from the discussion, this is an order of n time complexity and order of n space complexity algorithm. Thanks everyone for watching. We'll come back with another problem.